All right, let's hit the ground running. Here's example 1. We are going to integrate 3x squared plus 7x minus 2 over x cubed minus x squared minus 2x dx. Now, hit that criteria first. Criteria number 1, first of all, can you ever do a u sub? That's always step 1, right? And we cannot. So I just gave you a second to look at that. You cannot, because let's just assume we're going to do the u of x cubed minus x squared minus 2x. My du here is 3x squared minus 2x minus 2. That is not the same thing, right? So my u sub is out. Then I look at this and say, oh, do I have the same degree or is the top bigger? No, because my numerator is squared and my denominator is x cubed. Okay, now factor the denominator. You can have a greatest common factor of x here. That gives me x squared minus x minus 2. Ooh, we could factor that again. X minus 2, x plus 1, right? Simple linear factors. So once I factor this out, I now have simple linear factors. So step 1, factor the denominator. Check. Step 2, now let's look at what this partial fraction decomposition looks like. We are going to have our, just what we're given over here. We're dropping the integral symbol because we're going to take that rational expression, break it up into something that we can integrate. So basically, we're going to do a whole ton of algebra to make our calculus easy. That's our goal here. 3x squared plus 7x minus 2 over x times x minus 2, x plus 1. So your partial fraction decomposition is you're breaking up those linear factors. So I'm saying I have some a, which is my numerator, with a denominator of x, plus b with a denominator of x minus 2, plus c with a denominator of x plus 1. So I'm taking those fractions and I'm splitting up. That's that decomposition part. I'm splitting up those linear factors. Then step 3 is clear the fractions. I'm going to multiply through with my common denominator. And remember, when you have a common denominator, you just have to represent. So I'm multiplying this by everything. My first term here to each partial fraction decomposition. So this whole thing cancels out. And then on the left, I have 3x squared plus 7x. That 7 looked wonky donkey. Minus 2. Then over here, I have, I'll go back to purple. This x cancels out with this x, but I have these left over. So I'm going to write this as x squared. No, I'm not. We'll just write it as x minus 2, x plus 1. For b, the x minus 2 cancels out, and I'm left with x times x plus 1. Do you see what's happening? The x plus 1 cancels out. I'm left with x times x minus 2. So you're eliminating the fractions here. Go back to black. And now I have a times, and we're going to distribute this. So I have x squared minus x minus 2 plus a bx times x plus 1 plus a cx times x minus 2. And you no longer have fractions. That's the key. All right? I want to break this down to where I'm not looking at my fractions. It's an equation. Anytime you have a rational equation, you can multiply through the common denominator. As long as you're multiplying both sides, you're good. Okay, now let's distribute and see what we're working with. Oh, why did I switch to blue? I don't know. So I've got 3x squared plus 7x minus 2 and ax squared minus ax minus 2a plus a bx squared plus bx plus a cx squared minus 2cx. All right. We're just solving an equation is what's going on here. But now I say I've got squared terms that we can put together. We've got x that we can put together, right? And then you just have this variable by itself. So combine your like terms. Scoot this up. Notice we haven't messed with this 3x squared plus 7x minus 2. It just hangs on. So I now have, for the x squared, I have the coefficient of a plus b minus 2c is the coefficient of x squared. Do you see that? No, it's not. Ooh, good job, guys. Good, see? I was looking over here and my eyes went there, but that's not an x squared. This one is. Good. Good job hollering at me, because I know you were. And I appreciate it. I can hear you through the computer. Okay, plus, and then I look at the coefficient of just my x. So I've got negative a plus b, and there's my negative 2c. And then plus, and I'm just going to write this negative 2a, even though it's just by itself. I'm going to write that in parentheses because now is where we're looking at this other one. 3x squared, my 3 over here for my x squared is the same as my a plus b plus c for my x squared over there. So a plus b plus c equals 3. This is an equation, which means the left side equals the right side. So if I have a coefficient of my squared term, then the coefficient over here is equivalent to that. I see how this is working out now? So we do all this work so that we can figure out what these values are, and based on the coefficients. So I now have negative a plus b minus 2c is equal to 7. And negative 2 is equal to a negative 2a. Negative 2a is equal to a negative 2. It is amazing when you have a single variable by itself, because you can solve for that. Now, remember how we said most likely you're going to be using systems of equations. It's because you get this set up, and now I have a, b, and c that I have to solve for, so I can put those as my numerators. So right here, when I divide both sides by a negative 2, I know that a equals 1. If a equals 1 here, it equals 1 here, and it equals 1 here. So for red, we have 1 plus b plus c is equal to 3. So b plus c now equals 2. For blue, I have negative 1 plus b minus 2c is equal to 7. So b minus 2c is equal to 8. Now, we have b plus c equals 2 and b minus 2c is equal to 8. We have a system of equations, right? So I can look at those two systems and then we can solve it. So remember, back to algebra, when you solve a system of equation, you have substitution, you have elimination. We are going to use elimination because I can just make all that negative, and then these b's cancel out, right? Go back to black. And I have 3c is equal to a negative 6. So c is now a negative 2. So I know a, I know c. Now, plug it into anything, and you can figure out what b is. Once you know two variables, then you've got your life set up for you, basically. I'm going to take this top one here. I don't know. I'll just go back to black. I'm going to take this top one, and where I have a plus b plus c is equal to 3. I now have 1 plus b minus 2, that's a b, is equal to 3. So b minus 1 equals 3. So b is equal to 4. You could also take this c, plug it in here, right? So b plus 4 and equals 8 minus 4, and you still get 4. It doesn't matter. Once you have these, you can plug them back into however that works out, because your ultimate goal is to get these 3 values. Once you have those 3 values, then, I'm going to squeeze this in a little bit, you now know A, you know B, and you know C. So I can now integrate and say A is 1 over x plus B is 4 over x minus 2 plus C is a negative 2 over x plus 1 dx. And now we can easily integrate. Do you see that? Sweet, right? We had to do this fraction decomposition, partial fractions decomposition, because we start with an integral that we can't work with. So we do this pile of algebra here so that we can get an integral that we can work with. Once you get that integral, I'm going to make this nice and big again. Once you get this integral, this is just direct integration. Remember how I said natural log never goes away? E never goes away. We're going to see them a lot. Right? Here we are. The natural log of the absolute value of x plus 4 natural logs of x minus 2 minus 2 natural logs here of x plus 1. It's indefinite, of course, so you put in your plus c. Then, because this is natural log, you can go through, right, and simplify this and work this up. Oops. I meant to do this. Take your 4, put it as an exponent. Take your 2, put it as an exponent. Minus means divide. Plus means add, right? So, you could, I would totally take this, by the way, 100% of the time. Or you could clean this up a little bit, and you could be right. X times x minus 2 to the 4th over x plus 1 squared. It doesn't matter to me. I am good either way. All right? But that's the key. Look at this. Once you do the partial fraction decomposition, how easy was that integration? Super easy, right? And I know this x minus 2, if you were to do a u sub, that just is 1. That is 1. So it's just straight to your natural log. Don't try to do a u sub for that. We have now gone past that. That was chapter 7 stuff. We're past it. So now keep moving forward with it. Okay, good. Notice the farther we get with all this integration, what's happening? Full page problems. Full page problems. I told you it was coming. I know you were so waiting for it to happen, and it's here. Oh, that's so exciting. Okay, let's do more.